morning, one and all. Today we are going to solve a simple problem in a hydrothermal scheduling. So in that we are going to find out this TS star. To TS star. Already we have discussed this hydrothermal scheduling in our previous classes. So optimal like steam power generated from the hydropower plant. So here TS star is nothing but total time taken by the steam power plant. Take down this problem. A hydro power plant and a steam power plant are to supply a constant load of 80 megawatt for 1 week. That is for 168 hours. So for 1 week, it is 168 hours. So 24 into 7 is 168 hours. The unique characteristics are hydro power plant. The unique characteristics are hydropower plant that is given by Q is equal to 250 plus 10 into pH, that is acre-ft per hour. So for hydro, that power generation from hydro should be within 0 to 90 megawatt. And for steam plant, they have given H is equal to heat rate H is equal to 50 plus 11 PS plus 0.02 PS square. And minimum and maximum operating limits for steam power plant is 11.25 megawatt less than or equal to PS less than or equal to 45 megawatt. Solve for TS star. That is time taken by the steam power plant. That is optimal time taken by the steam power plant. Star is nothing but optimal time. Optimal time taken by the steam power plant. That is the runtime. That you need to find out. We need to find out the TS star. Let a hydropower plant energy is limited to 10,000 megawatt hour. So this is not given, but we are just assuming that hydropower plant energy generated is 10,000 megawatt hour. The total time, T max hours, that is given as 168 hours. 168 hours, that is given in the problem. Sometimes this time will not be given. So you need to calculate. So because 1 week is given, no? So 1 week into 24 is 168 hours. So that we need to calculate in some cases if it is not given. Now the total load energy is given as the total constant load is given as 80 megawatt. So the total load energy is equal to 80 into 168 hours. So that is nothing but 13440 megawatt hours. So that is the total load, that is total energy from the load. Next, thermal. Load is equal to steam energy. Load energy is equal to steam energy plus hydro energy. Already we have seen in our previous classes, that is in hydrothermal scheduling. So from this, what is the steam energy? Steam energy or thermal energy E. Capital E is equal to load energy minus hydro energy. Load energy, what already we calculated, that is 13,440 megawatt hour. So hydro energy, what we assumed, what we considered is 10,000 megawatt hour. So here we are substituting and we are calculating the steam energy E. So steam energy E is equal to this minus this. So we are getting the answer as 3440 megawatt hour. So that is nothing but steam energy generated. Steam energy. Okay, steam energy generated. That is E. E is nothing but 3440 megawatt hour. Now we are calculating the PS star. PS star nothing but power generated from the steam. That is PS star is nothing but optimal power generated from the steam power plant alone. So we already derived this equation. PS star is equal to root of A divided by C. So what is A? What is C? That is given in the problem. So from the heat rate characteristics, this is A. This we are constant term, we are considering as A, and this term A plus B P into PS plus C into PS square. So that is the general formulation. But in our previous problems, we consider as A into PS squared plus B into PS plus C. But here in the hydrothermal scheduling, we consider in the reverse manner. So A plus B PS plus C into PS squared. So similarly, you take, because already that equation is derived in this form. That is A plus B into PS plus C into PS squared. So better we also taken the notation as this constant term as A, and this term as B, and this term as C. So from this, what is C? So C is 0.02 and A is 50. Just substituting here, PS star is equal to A divided by C. So 50 divided by 0.02. Here, simplifying and taking square root of 50 divided by 0.02, because PS star is equal to root of square root of A divided by C. So here, while simplifying, we are getting the answer as PS star is equal to 50 megawatt. That is nothing but optimal power generated from the steam power plant alone. Now we are calculating TS star. That is whatever they asked in a problem. That is the total runtime for the steam power plant. Total time operated or total runtime for the steam power plant alone, or otherwise in other terms we are tell like optimal runtime for the steam power plant, or total runtime for the optimal steam power plant. So whatever you tell. So TS star is equal to E divided by PS star. Already this equation also already we derived. So that video also I will give in the description. You can watch, and after that you can solve this problem. So TS star is equal to E divided by PS star. So E total energy, that is steam energy, E is equal to 3440 megawatt hour divided by PS star is 50. So here substituting here, so we are simplifying, we are getting the answer as 68.8 hours. So that is nothing but total runtime for the optimal steam power plant. So that is 68.6 hours. So here, this only the resulting schedule will require steam power plant to run at 50 megawatt. So 50 megawatt already we calculated. How 50 megawatt in the sense the A is nothing but 50 megawatt. The resulting schedule will require steam power plant to run at 50 megawatt. Okay, so if steam power plant is 50 megawatt, means what is hydro power plant? That is 30 megawatt. How? Because the demand is given as 80 megawatt. Okay, so demand is 80 megawatt. For steam power plant alone, we calculated the optimal power generated from the steam power plant is 50 megawatt. So obviously, hydro power plant is 30 megawatt because demand is 80 megawatt. So hydro power plant, the optimal power generated from the hydro power plant is 30 megawatt. That is operating for 86.8 hours. So this is not asked in the problem. So, but even though you should know, sometimes in the problem they may change this data and they may ask, instead of they may ask TS star, and also they may ask so what is the scheduling time, or what is the optimal power generated from the steam power plant and hydro power plant. So optimal power generated from the steam power plant is 50 megawatt, and obviously optimal power generated from the hydro power plant might be 30 megawatt only, because the total demand is 80 megawatt, and the operating hours also we calculated, that is 68.8 hours. Total runtime for steam power plant is 68.8 hours. So the same time only hydro power plant should run, because this is in economic dispatch. So the same time, because we are doing the optimal scheduling for hydro and thermal power. So once you watch that previous video, that is whatever I have given in the description, so you can understand clearly. So in that we just compared what is the, if the this is the optimal power generated from the steam, then what might be the power generated from the hydro power plant. That we calculated, and finally we derived this part, that is PS star is equal to root of A divided by C, that we have derived. So hydro power plant that is operated for operated maximum power generated from the hydro power plant is 30 megawatt, and it is operated for 68.6 hours. So like that, you need to solve this problem. So data might be vary. The same thing you need to do whenever so this they may ask for 2 mark questions. Sometimes they may ask and 5 mark question also, because I think hydro power, whoever doing this hydro power scheduling, definitely without that derivation, without that optimal scheduling of steam power plant derivation, you can't study this particular unit. So definitely you'll be knowing this particular that derivation. So easily you can solve this problem also. But this problem seems to be somewhat confusing, but once you solve it, is very easy. Only one thing. So you need to calculate E, that is steam power generated from the total load energy. And after that, optimal power generated from the steam power and whatever they ask. So here they ask total runtime for the steam power plant. So if they ask hydro power plant and steam power plant also, you should calculate. That's all. Very simple problem. You may expect in our exams also. Thank you.